before 1850, there were some measurements done on ships, mostly air temperature measurements, but a little bit of bucket-based sea surface temperature measurements. But in 1849, I believe, there was an international agreement to start standardizing the measurements of temperatures on ships. They figured it would be a useful thing to track. Back then, most of the sea surface temperature measurements were done, as you mentioned, by throwing a bucket overboard, a wooden bucket initially, pulling the bucket up the side of the ship, and measuring the temperature in the bucket. Now, the problem with that is, depending on how long you wait before you measure the temperature, you can get a different reading. Depending on how tall the ship is, it changes how long it's going to take you to pull it up. The water can cool a bit or warm a bit, depending on the difference between water and air temperatures. And the instrument you use is going to give you slightly different readings. Also, so they started with wooden buckets. They switched to canvas buckets, which were easier to use but had different thermal properties, so it changes the amount of that the water cools. After the canvas buckets, the next big technology that was used for ships was engine intake valves. So you have a valve on the hull of the ship where water is going through, it's contacting a thermometer, and you can take the measurement. And more recently, we've been transitioning over to buoys, which sit in the water. They automatically send their data up to satellites in real time. And each of these different measurement systems has a different reading. They're going to have sort of an offset based on how much the water cools or warms before it hits the sensor. And if you don't do any adjustments, if you just use the raw readings for these things, you're going to see sudden big step changes in temperature when you switch from wooden buckets to canvas buckets, or from canvas buckets to engine intake valves, or from engine intake valves to buoys. And if you just sort of splice these all together, you're going to get a record that doesn't make that much sense. And so what we do to try to figure out how to adjust for different measurement techniques is look at these different measurement techniques side by side. So what do ships in the same area, one of which is using wooden buckets, the other using canvas buckets, what are they measuring for temperature? How does that differ? Similarly, if you look at buoys, side-by-side engine intake valves, how do those differ? Similarly, in surface and land temperature records, you have changes in instrumentation. For example, a mercury thermometer versus an electronic thermistor. You can look at those side by side, and you're going to see small differences in the offsets. And these small differences of like half a degree, for example, can make a big difference if you're looking for a signal of half a degree warming over a century. And so not adjusting for these sort of things is going to give you a misleading impression. That said, if you don't adjust for them, if you use the raw data, you still effectively get the same result. You still get about 1°C warming globally in the last 150 years. So it's not that you have to do these adjustments, it's that doing the adjustments gives us a better continuous record, specifically locally, where adjustments can have a much bigger impact, and therefore they're fairly important.